Hello, everyone. Thank you so much for joining us today for the Untangle Tech Talk series. Today, we'll be discussing all of the advanced networking options that are available within Untangle's NG Firewall platform. My name is Shannon Bonfiglio. I'm part of the marketing team here at Untangle, and I'll be your host today. I also have with us John Coffin, our Director of QA, and he'll be going through the presentation and going through all of the advanced networking options and, of course, answering all of your questions along the way. Just a few housekeeping rules before we get started. Please be sure you are selecting the correct audio preference on the right-hand side. If you do select to use a phone, you will need to dial in and use the access code that's provided. As always, we have a few members on hand to help answer questions, so please submit your questions in the questions tab on the right-hand side. If you have a very specific networking question, we do recommend posting your specific question on the forums, or you can email us at sales@untangle.com or support@untangle.com to get that specific question answered. As always, our webinars are recorded, so you'll be able to rewatch or revisit or share the recording at any time you wish. They'll be uploaded on the Untangle YouTube channel within 24 hours, and for those that registered, we'll get the link. So before I pass this over to John, just want to reiterate, this is a very technical webinar. So if you're new to Untangle or new to networking concepts, then this is definitely not the right webinar for you. We have a higher level webinar series called the 101 webinars that are more suited to you if you're new to Untangle or networking concepts. So please take a look at our website for all of those upcoming webinars. And with that, I will pass it over to John.
Thanks, Shana, and thanks everyone for joining us. The advanced networking, there's a lot to cover here, so we're going to go a bit quick. Feel free to rewatch this video and look through over some of the areas that maybe we went through kind of quick. Also, I want to state too, the forums are great help, especially if you can show a diagram of your networking. We can definitely help you on the forums. There's several engineers that are constantly looking at questions on the forums and trying to cover ways to help you and kind of make it clear how some of that broadcasting goes. So with that, some of the things we're going to cover is port forwarding for servers and so forth behind Untangle to protect them. Using NAT rules when you have multiple internet IPs to redirect the traffic the way you want it to go out to the internet. We're going to go over some VoIP configurations on how to use that. We're going to go over something called VRRP, which is high availability. Those are the cases when you have multiple untangles handling traffic, and they will hot swap automatically based on whether the machine goes down, a particular cable goes down, or anything like that. It'll hot swap to your other untangle. We'll also cover VLANs, and then there's a new feature in 13.2.1 which just got released, which is BGP and OSPF routing if you're doing broadcast routing for the internet. So with that, we'll start covering some of the easier topics. Port forwarding, really simple way to do. Generally, if your untangle is a router, which means you're natting traffic to protect your traffic on the inside, but you need some traffic coming in, you're going to do a port forward. Super easy to do. We have two ways of doing it. So we just go to networking and port forward. When you click add a rule, it's going to give you the basic form. This form, it's kind of a wizard where it will do the most common cases, and it will set up everything that you need for that. So let's say I have a web server behind my untangle I want to direct traffic to. It's going to say I want port 80, and then I'm going to give it the IP address of my server behind there and just say, hey, redirect any traffic coming in to my web server, to my untangle, direct it over to my web server so they get access to my web server. Super easy to do. Let's say you're only doing HTTPS, you can set that quickly and you're done and you're finished with the rule. If you want to do something a little more complex, you need to switch to advanced. It takes out all the rules that you had in there, so you'll have to type it again. Again, it'll pre-populate it with most of the common things. Destination local means traffic that's destined to the outside of your Untangle. That's meant by destination local, which means any IP that your Untangle has, the traffic going to it will be redirected, in this case, to a web server that I have behind there. If I want to do something a little more involved on that case, I can say I want to get rid of this particular rule, and I want it to only go to a specific address. So in this case, I'm going to say if the destination address, which is the outside of my box, I'm only going to use this address. So this is the WAN address of my, I could have multiple ones of those, but I'm only going to redirect traffic if it comes into this particular IP address. So as you can see, I can start building rules that are more complicated. And then let's go a little further and let's say I don't want everyone on the internet to have access to my web server. I'm going to allow access from, let's say, one of my other offices. So I'm going to put the IP address of my other office, and this would be the public IP address of it, and say only people coming from this source address will be able to access my web server. And as you can see, we just build a more and more complicated rule. So in general, you want less conditions to meet your minimum requirements. So you don't want to add rules that will be redundant. Like on this case, I don't want to add a condition destined local, because since I have the destination address as my WAN address, this is redundant with destination local. So I don't want to have that. That's just going to be redundant. I can specify protocols I want to use, so forth, and that is your basic port forward rule. I can go back and edit that, and goes back to whichever way I have that set up. So this is your basic port forward rule. And again, you can have multiple IP addresses. Let's say, on your interface. In this case, I only have one IP address, but let's say I add another one. I add another IP address. So my Untangle will have multiple addresses on its configuration, and this is going to be 16. So in this case, I have two IP addresses on my network for the outside. So then I can create port forward rules. Like this one is on this address. I can create a different port forward. Even though I'm going to use the same port 80, I can have it, I can say I want to have people coming in to my new IP address, which I just typed in, and I'm going to send that to a different box. Excuse me. You can have, this way you can have multiple web services, multiple mail services. Even though they're using the same port, they're coming in on a different IP address based on the IP addresses on the outside of your Untangle. So that pretty much covers general port forwarding. And again, you can use different ports, you can use different IPs and send them out to a different one. While we're on this subject, one of the things you can do is, for example, if I have a specific IP address that the web server is going to come in on, I want that traffic to go out that same one. So I will use my NAT rules. So I'll say, my web server. So I'm going to say if the source address is my web server, I want it to go out a custom IP, and then I'm going to tell it the IP of that I want it to go out to. So I make sure it goes out this specific IP. This just ensures that the traffic coming in, anytime my web server goes out and does a request, it always goes out through this IP. And that makes it easier for tracing traffic and so forth. It also makes it easier if you're doing session-based web authentication. So if you do an authentication on a session, when you come in again, it will always show the same IP, even though it could go out another different IP. So it will always show this particular IP, and that makes it clear for what it needs to go through. And that's the basic ideas between NAT rules. And a lot of times they're used with port forwarding. In general, you don't need to do a NAT rule for a simple port forward. It's only you want to do a NAT if you have multiple web interfaces or you have multiple IPs on each interface. Again, simple rules are best. It makes it pretty clear. It's almost guaranteed that you won't make any problems. Less conditions, it's going to be less troubleshooting. The more rules, the more complex the decision making is, harder to figure out why your port forward's not working. Use local DNS entries. So if you want your people on the inside of your network, so they don't have to go through going outside back through Untangle, you can go through and say, I'm going to say my web. I could say, www.example.com is my web server, and I will give it the internal address. This enables all the people on the inside of my network not to have to go through the port forward and put extra load on my Untangle. They can just go direct on the LAN to the web server, and it makes it a little easier than that. It's one way to kind of reduce the traffic going through your Untangle. And again, use your session viewer. Makes it really handy to see what kind of traffic's coming in and seeing what port and so forth the traffic's coming in. You can see the traffic coming in on your IP, and then you can see where it's actually directed. Going on, I know this is going kind of quick. Definitely post on the forums if you have specific questions. One-to-one NAT. We kind of used an example of why we use one-to-one NAT. If we have multiple IPs on our system and we want to make sure some traffic behind the Untangle goes out a specific IP, we'll use NAT rules. Here in a case, we have multiple WANs. So we have a second WAN here, which is addressed right here. This is a WAN. If we want to make sure the traffic goes out that one, we'll say, we can say things like, we want the source address, and we can put a range in here. Let's say we want all the traffic from a specific range to go out. Let's say we want to go out a specific IP. So we'll have it go out through the second WAN using our NAT rules. And that makes it pretty effective for the traffic going out. And so all this traffic will go out the second WAN because this is the IP of the second WAN. That's one way to do that. The other thing is port forwarding. Again, great way to assure that the traffic that is being port forwarded is going out the same IP if it has some kind of request to make outside. Again, that's only necessary if you have multiple WANs or if you have multiple IPs on those WANs. VoIP considerations. In general, Untangle will bypass your traffic for your VoIP automatically. And if we look at the bypass rules, you'll see some built-in default rules. Any kind of destination to 5060 will be bypassed. Also, any kind of 4546 will come out. I actually go a step further, and I do either one or two things for my VoIP phones. I'll either put them on a specific IP range. So, for example, I will put all my phones, let's say the source address, I'll put all the phones on a range of, let's say, 10.200 through probably the end of that. So let's see, we have 10. So I'll put all my phones in this range from 200 to 250, and then I'll make those bypass. So it's a simple rule. It makes it bypass. Or I will even put all the phones on a separate range, completely different network, and just say, you know, all the phones are on this network, so I'm going to bypass all the phones. It's just a way that a lot of times, since most phones use UDP, the Untangle, if it starts scanning the sessions and looking for things in the session, it can mix the session packet order, and that causes for interruptions in the calls, some dropouts and so forth. So it's best just to go ahead and bypass all your phone traffic from your Untangle. It makes it pretty easy. So now we're getting into a little more complex areas. There's something called VLANs, and really VLANs have a lot of mystery on them, but they're just a way to have two lines of traffic going through the same wire. And what they do is they encase the traffic in a label, so the other traffic ignores that label and just redirects it based on switches. So there's two parts to VLAN. So you have a VLAN, and it's actually going down the same wire as a different traffic. So there's two things you need to do. You need to make a virtual port, and this virtual port is the VLAN. So you'll have your normal port, and then you'll attach a VLAN to that. And that's that second wire that goes through there. So now we have the traffic combined into one wire, and then we have to have a way of separating that traffic once it gets to the endpoint. And there's two ways to separate that. Some devices themselves will have VLANs, but the most common situation is use a managed switch. So you'll label a particular port on the switch a certain VLAN. So as the traffic comes down the same wire, the switch will say, oh, this traffic has a special label. So it will go out a specific port on your switch. And that's really easy to do on Untangle. You just go over to interfaces. And let's say I'm going to go ahead and use my internal, but I can use any of the interfaces to make a thing. So I'm going to add a tagged VLAN interface. I'm going to call it, internal 2 in this case. And it really doesn't matter what you call it, just something you know. I'm going to make it paired with my internal interface. I'm going to go ahead and make this address. And then I'm going to give this a whole different IP range. So in this case, I'm just going to do 21, and then I'm going to make it a standard 24. So now I've created a separate interface, and you'll notice it shows up as a different interface here, and it's a separate thing. So then I would go over to my switch, manage the switch, and one thing I forgot to do was give it a label. So automatically gives it a label 1. So I'm going to label it 20, just so I can keep track of it. So label 20 is the 20x.network. And you don't have to have this related. This just makes it easy for me to understand it later on when, 6 months down the road, I have to make a change. Like, okay, what was VLAN 20? What network was that? Or I see an IP address, I'm like, which LAN is that on? It just makes it easier. So I'll go ahead and save that. So once I save that, I'm going to go over to my switch, and I'm going to say, okay, I'm going to make a certain like port 23. That is going to be a separate network, so I'm going to put a label on that inside the switch, and say this has a tag of VLAN 20, and that tells the switch when traffic comes in, it just sees the complete top layer of the traffic. So then what I'm going to do is go ahead and the switch is going to divide the traffic then between the tag 20, which is going to go out that port 23, and then the regular traffic, which is going to go out to the other ports. And that's how the two areas go. So now I've made a VLAN. So I've created a label on my switch, and I created a layer on my label on my Untangle. This allows me to basically hide this other traffic, the VLAN traffic, from the regular traffic going on even though it's going on the same wire. And this really acts like any other interface that you have, any other physical. You can set it for static, you can set it for DHCP. If you have some reason like you're hooked up to a special kind of ISP modem that requires a VLAN, you can make this a WAN interface. You can do DHCP on that specific area. So there's all kinds of changes that you can make. Oh, sorry, I was on the wrong one. So I can make this a WAN. I can change the tags. I can configure DHCP on it. It really acts just like if I added a new NET card. The only thing is it's traveling over the same wire as my internal interface. So these two are actually physically connected, but logically they're two separate interfaces. And you have to have a way of separating them at the other end, either by the terminating device has to be able to recognize VLANs, or more commonly you use a managed switch which handles VLANs. Most of your managed switches will be allow you to label ports based on which VLAN it's on. That's really the basics of the VLAN. So there's so much involved in that. I can only scratch the surface on that. And it's, again, one of the best techniques you can have to see what's going on is looking at your session viewer, see which traffic. You can actually see the actual physical interfaces going out of, and that will show the VLANs also. So you can tell if the traffic is correctly being tagged based on what interface it's showing. You can see where it's going to, and then there's also troubleshooting similar to this on managed switches to look at that. You'll notice that my VLAN shows up as an internal, in this case, an internal network. It's just another network on the card. So it's physically, even though I haven't added another net card, logically it looks like another net card. And that's the biggest thing to learn from that, is how net cards work and so forth. Some of the other parts, VRRP. What is VRRP? It's a way of safeguarding hardware. Anytime you have a physical device, no matter how robust, it's prone to failure at some point. So the way to prevent your network from going down is you would set up two untangles, two or more. I'll show you a case where I have 3 untangles set up in parallel. So the way it works is only one untangle is actually handling the traffic at any one time. And what it does, there's a message that goes across the untangles and asks if we call them the two slaves in this case. We only have one slave, but this slave will constantly talk to the master and say, hey, are you still alive? If it gets an answer back, this is alive, it'll stay dormant. But once it doesn't get a response from the master, the slave will become the master and handle all traffic and redirect it automatically. To the network on the inside, it will not see any difference of which one it's going through, because there's something called a virtual address. So you have to give the VRRP an address separate to the one that's actually on Untangle. So in this example, we have two Untangles, but it's you are required to have 3 IP addresses. So you're always required to have one more IP address than the number of Untangles that you're putting in your VRRP hot swap group. And it's a kind of a hard concept to kind of bring around, but it's actually, Untangle makes it really easy to configure it. So in this case, we'll just set it up very similar to this. You don't necessarily need to have a VRRP on the inside and outside, but it's recommended, because if either one of these networks fail, it will automatically redirect. So the master has to have both of these working. If either one fails, it will automatically switch over to the slave. And I'll show you an example of that. So in this case, you'll see this designation. It says VRRP on the thing. So this tells me that this particular box right here is the master because it has the label. So we'll look at one of the slaves right here, and you'll notice it has the same network, same configuration, but it does not have the VRRP. And you notice there's almost no traffic going through this box. That's because it's dormant and it just keeps talking to the master one, which is this one, and saying, are you still alive? And when the master responds, it just goes into a dormant state. I've literally physically unplugged the masters in this case, and I've literally seen no interruption in my video request. It's just super fast the way it's switched, and it's just a great way of ensuring that your hardware will stay up. So let's look how to configure this. So we're going to look at a couple things. First thing we're going to do is we're going to have to create a VR network. So what we'll do is we'll go to our WANs and we'll go through, we want to make this a VRRP. We're going to give it an ID. So the ID is what connects these two interfaces together. So these two interfaces need to have the same ID but different weights. The weight tells it which one is the master. And again, same way here. These will be different IDs because this is a different set. So you have to think of set of networks. So I'll go over here, and I'm going to give it an ID of 1. And since this is master, the higher the value, the better. So, the more it's going to be the master. So I'm going to give it a weight of this. And then I'm going to have to give it an IP address. In this case, I gave it 2 IP addresses because I had extras. So I just made more and more addresses available to the VRRP. So I could add more slaves also. So that's set up on that one. And we're going to go ahead and do the second WAN. So we're going to set that up. Again, this is a separate group, so I'm going to separate that out. And then set the weight. I'll put a similar weight that I had on the other ones, but it's a different set because it's a different set of IPs. And again, I need to have a VRRP address. I have to have at least one address there. This is where the traffic's actually coming in on this IP address. And then it gets redirected based on which one is the master. So once I have that set up, my first box is ready to be a VRRP. So I need to set up the next box. So what I'll do, the same way, I'll go to network settings. And even though the actual physical address of this box is different, if I go to my VRRP, the address is the same as the first box. So I'm reusing these addresses from the first box because this is the virtual address that it sees between the two of it. Again, it's I'm setting this up with the same ID as my other box so I can match the NICs on that. So each set of NICs will have the same ID that are going to be in the group. And of course, it's going to have a lower priority because I want to make this one my slave. So I'll go ahead and put that in there. So once I set that up, if you go to your master, you'll be able to see that it's recognized as the master. And you can actually just test this really simply by pulling the cable on one set of the NICs, and you should automatically see the traffic start flowing through the second box. And there's really no limit to this. I think the limit's like 255, but if you want to put 2 or 3, it's not really, unless you have a high failure rate on your hardware, more than 3 is probably not needed. And that's really the way, so the traffic actually literally travels through this virtual address, but where this address is just depends on which one is signaling that it's still alive. So it'll be able to redirect the traffic through that. One thing with multiple high availability VRRP setups is you want to keep all your rules the same. And one of the there's 2 ways to do that. You can use Command Center to push out your properties to each of the boxes that are configured in the VRRP. I have used for years just doing a system backup. And the way I do it is I'll go over to my master and take a backup file of that. Then I'll go over to my one of the slaves, and again go to instead of backup, now I'm going to go to the restore config. Now I don't want to do a full restore because my IPs and all that are going to be different on the slave. But what I do is I do a restore everything except network settings, and then I restore the file. That keeps all my masters and slaves all synchronized together in that. And really that's the way you keep everything in line with it, the policies and so forth. Generally, I don't change the policies, so an easier way is to do it through Command Center, and that way you don't have to hop through the different machines. Command Center can actually push out those policies to each box. So a new feature for 13.2.1 is BGP and ODF. Generally, most people don't need this. If you have a very complex system that's going through tunnels and so forth, and you have changes and multiple routers on each end, you will need this for broadcasting your areas. This is a pretty new feature. We're using it in a few environments to kind of configure that out. Here is a BGP test setup, and it's pretty easy to set up once you understand all the other settings. So what I'll do is go ahead and go to networking, just to give you an idea what this network looks like. Let me just give you an idea what this network looks like. So here's my network. So I have the Untangle here. I have all these routers behind there. They're redirecting traffic. As you see, this actually has redundant routes. So I need to have a way of the Untangle and other boxes that are going through VPN tunnels to know about these traffics over here. So the way I do that is each of my specialized routers are broadcasting their routes to different areas. The Untangle will take that and then create its own routing table based on the broadcast areas of that, and also broadcast that out to other VPN routers. So the way I can do that is I'll go to my advanced settings, go to dynamic routing, and I'll set up my BGP. I'll give it a router ID, and that's the ID that I have specifically for this router. And then I'll set up the autonomous system address. And then I also put in what the neighbors are. So who are my neighbors and how am I going to broadcast addresses to that? I also, talk about if I need to add any specific networks for those to get to those areas. And then as you notice, this automatically will start talking to my other neighborhood BGP routers and pick up what they're picking up on as far as routes and so forth. Also, what kind of weights they have for their particular area, so I know which way to route the traffic. Same goes for OBF. If you're going, you need to tell it what kind of your network is and where you're going to get broadcast areas from it. You're going to have to talk about the backbone. What are the different backbones that you want to have? Any kind of interface overrides. Generally, I don't use that. And then if I need to make any advanced options. And with that, the machine will actually build its routes from that. And as you can see, even though I've only specified this route, this particular router is also telling me about these other networks that I have. And which one obviously, metric 20, I should use this one in most cases. But if for some reason that one's down, I can use this other one and it will be routed through that. So it's pretty a complex set of routing systems in there. And the best way, if you're having problems with this, again, kind of put a diagram up and let us know what you're trying to do, and we'll help you go through that, and we'll get through those different areas. This is a pretty complex area. I mean, this is generally for people who are doing, multi-building type routing systems. So if for most people, they won't have much use for this, but it's there if you need it. Again, that's with our 13.2.1 release, which is rolling out right now. And also, when you download the images, you'll get the 13.2, 13.2.1. Again, we went over quite a bit of things, and I'll go over some of the questions real quick. For debugging session viewer, I mean, it really sees what's inside your network. Look, reporting. One thing I didn't go over was we have this troubleshooting, and this makes it really easy to kind of go over your network. So you can do things like a ping test. You can ping different parts of your boxes, make sure that's working. We have DNS, make sure your DNS on your box is working correctly. Traceroute I find really useful because I can find what path it's taking to different parts of the network, and that works out area. And really, our packet test is a simplified version of TCP dump. It allows you to specify any kind of port or IP. And see the kind of traffic that's going across that, and see what you can do for that traffic. That kind of gives you an idea, like if you're not being able to get a certain path and you can start traffic across it, you can do a packet test to see where the traffic is going. So if you're seeing the traffic go out but it's not getting a response, there's probably something going on downstream. This is really useful when debugging VLANs. You're sending a ping down a VLAN, but you're not getting a response. Most likely, you have something set up incorrectly on a switch, or it's not recognizing the VLAN, or maybe you have a crisscross on the VLANs and so forth. Do we have any questions I could go over?
Hey, John. Yeah, we have a ton of questions. So I know we've been trying to answer as much as possible. So let's get started. Let's see. Does VLAN need to have DHCP server active, or does the attached Ethernet take care of that?
So anytime you add a VLAN, the parent interface is a separate interface. So you have to have DHCP active on the VLAN if you want to pass out IP addresses, because most likely that's going to be a separate network on that. So you really have to think of them as physically separate networks, just a physical net.
Okay.
I saw a question in there about VLAN introduces any latency. Anytime you're doing logic style physical connections, which is a VLAN, because it's a logical connection that acts like a physical. There's always some amount of latency, but literally I've seen less than 1 millisecond latency added because it's going through a VLAN. The amount of overhead is so low because it's actually done at the kernel level.
Oops. Sorry about that. So just a few more questions. Can you block or enable, sorry about that. Can you block or enable inter VLAN routing with Untangle?
Yes, so if you, through your, let me just show you that real quick. So by using the filter rules, you can literally block traffic in between it. You can say something like, let's say you have VLAN 20 and 3. So you can put conditions like destination interface, and as you notice, my VLAN is listed right here. And then I can say the source address is my other VLAN, for example. Sorry, wrong one here. Source interface. So I can say, in my internal, and then I can just say block. I can block the traffic going in between those two VLANs. Separate question. I saw somebody, it's like, if I have VRRP, do I need to Untangle licenses? And the answer is yes, you do. It's actually a separate box. What a lot of people do is they'll put the free license version on the slave one. So it keeps their network up, but it allows them time to transfer that license over if they want a full set of licenses on that. So ideally you would have licenses on both, but if you don't want to do that for costs, you can always put the free version on the second one. It'll keep your network up and give you enough time to transfer the subscription over until you figure out what's wrong with the first box.
All right. So there was a few questions about if people need additional Untangle licenses to cover 2 boxes for VRRP.
Yeah, so I was mentioning, so you do need a separate license if you're going to have all the applications that you have on your masters. What some people do is they put the free version, which is a limited set of applications, on the other one, mainly because what they're doing is, it's kind of a rare case that their hardware would go down, but they want their traffic to still go through, so they'll put the free license on the other one. They won't get as good as filtering as they would with a full license, but it'll keep their machine up, and then they would pass the licenses over there. Speaking of VRRP, I noticed someone said, does each Untangle need a separate external address? Actually, in a VRRP setup, you need a separate IP for each Untangle plus 1. So you need 1 for each Untangle, plus you need 1 assigned to the VRRP interface. So in the cases of you want 2 Untangles to be high availability, you'll need 3 external IP addresses plus 3 internal IP addresses, just so it's clear on that.
Great, thanks, John. Just looking through them.
One question I saw is, does Untangle work with other routers and firewalls? Yes, it does. We're actually, we've tested it across a couple other networks. We're talking about, I'm assuming we're talking about BGP. So yes, BGP is a just standard protocol, and we just implemented that so we can be both discussing what IP ranges we have and also receiving ranges from other networks. So as long as they maintain a standard to BGP or ODF, which almost every router, Cisco, just you name it, everybody router accepts BGP connections. We'll understand that and automatically, dynamically change the routing based on those conversations with the other routers.
All right, there's a couple questions about the slave server. Does the slave continue to query master even after it has taken the network load, or is it a manual failback?
No, it's the master will, it's based on weights. So whoever has the highest weight will, and is still alive, will take responsibility for handling the traffic. So as soon as you get, if it was a power outage or a bad cord or so forth, and you can experiment this yourself. You can literally have two set up, unplug the master from the network. You'll see the traffic already flowing through the second one. Plug the master in, and I would say within probably less than a minute, you'll see the traffic flow back through the master. The caveat with that, it's only new sessions. So if you're, for example, watching a YouTube and you started going through the slave, that traffic will stay on the slave because that's a session. Only new requests will switch over to the master. But as you can tell, that most sessions are pretty short. So within a few minutes, most of your traffic will switch over to the master.
All right, can you set up a VLAN with Untangle for only certain protocol traffic, or is it only port-based?
You can't, so you can't direct traffic based on a protocol because it's set at the tier 2 level. So to be able to do that, you need to have a switch because VLANs occur on two separate locations. It's the end of the tunnel and the beginning of the tunnel. So you would need to have a switch that would be compatible with that. So I've never heard of switches that are protocol based for VLAN switching. That's why it's more of a port type separation.
Okay, great. I think that's about all the questions for now. We're running a little bit out of time, so I wanted to just see what else is in our deck. So this may have been a little confusing for you, perhaps, or you want to do some of these configurations but need some help. We do offer professional services. So just take note of that if you want a little bit of assistance to figure out how to implement some of these configurations. Let's see. Next slide, John. We went over the questions. So if we didn't get to your question, or if you have a very specific question, please email us, support@untangle.com or sales@untangle.com, or like John mentioned earlier in the webinar, the forums is a great place for you to list your question if you have a specific question and want to get a quick answer. John and many of our other engineers are always on the forums to help. So while I have you guys, just want to mention our promotions that we have going on, a couple of them right now. Our security upgrade program, whether you have an older Untangle license or appliance or have a competitor's appliance and are looking at Untangle, we offer trade-in and trade-up program to entice you a little bit to go with Untangle. So contact us at sales@untangle.com or your sales rep to learn about that pricing. And we know everyone loves using us at home. We love our home users. So if you bring us to work, there's also some special pricing with that as well. Yes, this webinar was recorded. The recording will go up on the Untangle YouTube channel within 24 hours, so you'll be able to rewatch this in as much as you want, and share it with whoever you wish. I think that's the last slide. One more slide, yeah. So as I said, excuse me, if you have any other questions, please reach out to us. We're here to help. Thank you, John, for the great demo. I know that was a lot to cover in a very short time. So we tried to cover everything and hopefully answered all your questions. So thank you, everyone, and we'll see you next time.